channel. So we continue the discussion of this paper, which is based on anomaly detection, the Skip-GANomaly. Now in this session we'll be looking at the third component of the pipeline, which is the discriminator. Now we'll look at the generator, which consists of the encoder and decoder. Now we have the discriminator. Now the task of the discriminator, as we'll see in figure 3 shortly, is to predict the class label of the given input. So this is what is happening here. You will see here that this is the discriminator. So this part makes up the discriminator, and its task is to predict either real or fake depending on where the input is coming from. So if the input is coming from the original normal samples, then it classifies that as real. But if it is coming from the reconstructed samples from the encoder-decoder network, then it task is to classify that as fake. So now let's look at the loss function that is being optimized with the discriminator. So the discriminator loss function is this adversarially loss. So what is happening is that the discriminator is actually taking samples from the normal class, normal instances, and it's also taking the reconstructed samples. So we see at a high level, this is a cross entropy loss function. This is a binary cross entropy. So we're taking the log of that, and here we have 1 minus log of that, and so x is sampled from the probability distribution of the normal sample. So that's essentially what is happening there, and this is what is formulate the adversarially loss. And if you look here, we see more details about the discriminator. So that's just what this is saying. So the task is to classify real images X from the fake ones, which is the X bar generated from the generator network, which is G. So, and the network architecture of the discriminator follows the same structure as the DC-GAN approach used in this paper. So the network is also used as a feature extractor such that the latent representation of input image X and the reconstructed X bar are computed. So that's essentially what is happening there. All right, thank you very much, and see you in the next one.